Up next, we're going to be talking about powering giga-scale data centers, centralized versus decentralized approaches, and hardware and software innovations. For that, we're going to give a warm welcome to our panelists, Andreas Aepli, CFO of Reverion, Irena Spazzapan, founder and managing partner of Systemiq Capital, Paul Bogers, Director Technology Strategy and Ventures at GE Vernova, Tomas Kemtys, General Partner at Contrarian Ventures, and to moderate this session, we have James Lockyer, Director Climate Innovation Fund at Microsoft. Welcome to our panel and to our moderator. James, over to you.
Great stuff. Thank you very much. Good morning, everybody. Thanks for joining this morning's session. I know there's a lot going on today, so I really appreciate you guys making the time to join us today. We've got a fantastic lineup of panelists today representing from across investment and also innovation. I'm really excited to explore a few topics in and around the data center decarbonization space. And I think it's probably not escaped your attention that we are seeing a significant rise in demand for compute. With that comes a lot of incredible opportunity, particularly for innovation, particularly for productivity, but also for societal gains. But with that, then conversely, also comes some complexities in areas such as grid planning or long-term sustainability goals, to name a few. And so for our topic today, in terms of really exploring these two different types of data center models, one which is looking at, I guess, what you would call large-scale, efficient data center deployments versus more modular, decentralized, local data center environments. And so I feel like we've got a really strong lineup of panelists today. Let's do a quick round of introductions first. Perhaps, Andreas, we can start with you and then work our way along.
Thanks a lot, James, and happy to start. Good to be here this morning. So my name is Andreas Aepli. I'm the CFO of Reverion. We build modular fuel cell-based power plants that deliver, number one, 74 to 80% net electric efficiency in turning natural gas or biogas to power. Number two, they're reversible. So when there's surplus power, they can also generate methane and in the future hydrogen and feed that into the grid. And number three, they remove all the CO2 during the process, so they operate carbon neutral.
Thank you.
I'm the managing partner of Systemiq Capital in London. So I started Systemiq Capital 8 years ago. But I've been in power for more than 20 years now. So been around, asset-backed financing and power trading for more than 20 years. And yeah, anything with electrons, I'm always for it.
Excellent. Paul Bogers, I lead technology strategy and ventures at GE Vernova. And we think of ourselves as a 130-year-old startup. Think of GE Vernova as anything that doesn't fly, anything that didn't go in a hospital ended up in GE Vernova, Ver for green, Nova for new. So we play what I always call the full piano of the energy transition, whether it is large gas-fired generation, aeroderivatives, nuclear and hydro, onshore and offshore wind, as well as all of the equipment you need to make the grid run, probably with a bias towards transmission, so the large power transformers, gas-insulated switchgear. So it's a really interesting kind of mix. And the way the theme of this conference is around energy tech. Energy is now so much front and center in the thinking. So I love people who love electrons as well. But I think it's this is a really interesting time for all of us to start thinking about how we power the future.
Cool. I'll finish up. So I'm Tomas, one of the partners of Contrarian Ventures, climate, energy-focused VC fund. We've been around like Irena for about 8 years. And I would say when we started, I would not have thought that we'd be looking as much at compute and data centers as we are now, 8 years later. It's been a super big topic for us the last 2 years. So we looked at a lot of different innovations. So I hope I can share some learnings.
Great stuff. Thank you, Thomas. Thanks, everyone, for the introductions. And I guess to maybe quickly round out the Climate Innovation Fund team. So we're a fund that launched back in January 2020. We invest in solutions aligned to energy systems, industrial systems, and natural systems. We have a pretty hardcore, what we call invest to procure mandate. So the technologies that we invest in, we will also buy from and deploy them across our operations where possible as well. With that, I'd like to start by just letting the panel know that it's okay. I'm not expecting you to give us and really a solvable answer by the end of this panel discussion, but rather use this as an opportunity to explore, I guess, some of the innovation, some of the challenges, and perhaps some of the partnerships that are needed and collaborations across this ecosystem, as it takes a number of different parties, as we know, across utilities, policymakers, innovators, corporates, etc. So to kick off those discussions, I am curious, maybe Irena, if we can start with you. When we think about demand for high-performance computing and as it continues to grow, how are you thinking about the relative strengths of those large centralized data center campuses versus the decentralized environments? And what situations does each model offer in terms of clear advantages?
Yeah, so look, if you could, you'd always go fully centralized. It's more efficient for high-density GPU stacks, it's more efficient for cooling, but the reality is difficult, right? I think there were 16 gigawatts planned for new construction this year. There's only 5. And next year it looks even worse, right? And there's all sorts of issues that we know why these giga-scale data centers are not happening. But then when you look at, centralized distributed, again, training, inference, right? Training, it is what it is, you could do it anyway. But inference is where the action is happening. Like 90% of demand in AI today is in inference. And I think, I saw a report from JP Morgan that the cost of inference per token is down 99.7% in the last 2 years, right? So the curves are like that. But the problem in distributed data centers is that the PUE, the power usage effectiveness, is not as good, right? And so you need new hardware solutions, fundamentally, a new, better design, so that you can get those smaller distributed data centers down on the PUE, and then, and the direction of travel is there. I think the hyperscalers have tried not to do that, right? Because it is not the obvious thing to do. But the realities of the grid, the realities of the community engagement, are going to push us more and more towards the distributed world, of like 30, 40, 50, 100 megawatt data centers.
Awesome. You really have been in power for a while, haven't you? I love it.
But I guess in this place of all, we can...
Yes. And then, Andreas, how about from your perspective?
Yeah, so I think the large-scale data centers still can make a lot of sense, but they were a lot easier when grid connections were available, when electrical equipment was available, and today both of these things are really constrained, right? Grid connections, sometimes 2 to up to 10 years delays on getting into that queue. Also, these projects are really complex and large. They require a large amount of transformers and switch gears and all of these other things. And sometimes we're missing the engineering muscle, specifically in Europe, also in the US, less so in Asia, to actually build those large-scale projects and not have delays there. And I think the advantage of distributed is, aside like in interference, and I think there is advantage to take power in a much more flexible and distributed way, whether it's behind the meter power solutions like ours, or whether it's accessing some stranded power assets and coupling stuff together, or also opportunities like, for example, what Octopus Energy has been doing, flexibility portfolios to be able to access, even sometimes from residential power provision, and sort of coupling something together that is really hard at really large scale, but works a lot easier at smaller scale.
Great, thank you, Andreas. And Paul, any thoughts on that?
No, maybe two thoughts here, right? I think there's a lot of parallels with telecoms, right? So if you think about the telecom industry starting out, it was literally the most centralized kind of way. You had a switchboard, you had people literally connecting one-on-one, and that actually became far more distributed, not just to make it more, faster reacting, lower latency, but also to make it more resilient, right, in terms of network coverage. And then the second point I'd make is, beside the choices around the grid constraints and to maybe driving towards more distributed, where the data is held. So the concept of data sovereignty, around different nations or different kind of parts of the world, I think where that data resides, I think becomes important to governments, which then also drives you perhaps to less consolidation, less centralized, more decentralized.
Great, thank you. Let's switch topics, and Thomas, I'll come to you next, if that's okay. The role of technology innovation is obviously a huge part in terms of what we're seeing now around how to meet the demand. What emerging hardware and software innovations do you see as most meaningful in shaping future data center design and siting decisions over the next few years?
Yeah, that's we see a lot coming from very different directions and avenues. From hardware solutions to software solutions. So it's an ample. Time will tell what's the most effective ones. I think maybe what we've been looking at, let's say the last 12 months, a lot at different topics was one. And we mostly do Europe, so we evaluate European startups. We look at risks coming from the US, and so we have that kind of perspective. We looked a lot at the chip manufacturers themselves. Neuromorphic chips, we looked at photonics, and that always, this is super interesting, very deep tech innovations. For us as a fund, we always looked at the US, so look at Grok, Cerebras, so look at NVIDIA, and really, unfortunately think, okay, what right do these guys here have to win against those folks? And we hope they do have the rights, but we're always in the back of our heads. Cooling is another big space we looked at, from sort of bigger players that everyone knows already in Europe to something much more niche. Like recently we looked at something in Sweden in still lab stage, a new type of liquid cooling instead of water glycol mixes, which is the most commonly used now, that costs a few cents in the data centers. These guys are adding 2-3% of graphene, and it says it could save 20 to 30% of energy in terms of cooling. And cooling is about 40% of energy of a data center. So those type of things, a wide variety, I would say, of innovations, and yeah.
Excellent, thank you, Thomas. And maybe Irena, if I come to you next, for your thoughts on the role of innovation.
It's vast, right? But I'll mention two. There are areas we got very excited that we've actually invested in those spaces and we want more. So really, for us, it's all about power efficiency, right? So before you've even started using a GPU today, you've wasted around 20% of power, right? So the name of the game is how to reduce heat loss, right? And there's many different ways you can go around that. So one interesting one, which is actually interesting in data set, this DC world, right? I mean, alternating current is what we use in the grid today, right? But then EVs and batteries and solar, they use DC, right? Direct current. So the DC world has been around forever, ever since I remember, right? And it's been kind of a dead end of the power world for a long time. But in the data center world, this is now becoming like cool, right? Because you have 4 or 5 conversions from the main switch from the grid to the GPU. There's 4 or 5 conversions, and how you can do this in a smarter way, and and build like this whole inside rack DC. That's very interesting. And I think the other big thing, which is again in this theme of how do you heat is our enemy, is how do you get rid of copper, right? So we've backed a company that does something called co-packaged optics, which is really like when you do your ChatGPT thing at home or Gemini, whatever, right? It will travel with a optic-like, but when it actually comes to the data center, it will convert into copper, right? It will travel in copper, and that one creates a ton of heat dispersion. And so the future is very much to keep the optic signal all the way to the GPU, right? So that's another interesting. And and you go into this world of power electronics, it is real. I think that's where the action is happening, right? The Moore's law today is happening in power electronics because it's about density. If you think about Blackwell, which is being rolled out now, right? Blackwell is going to be up to 1,000 watts in a space like this, right? Rubin is going to be 2,000 or more, right? That's 1,000 watts, it's 1,000 amperes in physics, right? 1,000 to 1,000 amperes, that's the space of like a massive steel furnace, right? In a building that now has to go in a space like this, right? So this world of, getting rid of heat loss, power density, that's what we find by far the most interesting, which, you will have noticed that all the stuff that happens front of the meter, we don't find that interesting at all.
Yeah, understood. Thank you, Irena. And Andreas, your thoughts?
I think there's a lot of hardware innovation and software innovation that is happening. So hardware, for example, cooling is quite exciting, the efficiency gains we can get there. I'm going to focus on one thing on the hardware that is obviously behind the meter power generation, right? I think for too long the narrative has been there's renewable plus storage and there is build more grid, and that might be a little bit too binary. We'll need solutions that can integrate more with the grid and take advantage of the renewable power when it exists, but also not have a asset that only produces when there's no renewable power, but that can be operated and feed back into the grid and almost help to stabilize the grid. And the second thing is maybe on the software side, I think more flexible workload allocation with the data centers, more load following, but that also means that these companies need access to data. And a lot of the data sits within the utilities and is not easily accessible. So more data integration will help unlock more of these software efficiencies.
Yeah, makes sense. And Paul, how about your perspective?
Yeah, I totally agree with what the panelists said. We're equally excited around the power conversion, what can happen in the data center, all these inefficient steps, all these low voltage kind of things, and the ability of power electronics to make a solid state transformer that does a lot of those steps in one device, I think is a huge step forward. So anything you do inside the data center, I think is it's up for a new kind of reference architecture. A lot of work happening in that space. To Irena's point, kind of waste heat is your enemy because it implies low efficiency. You can also think about, can that waste heat actually do something useful? So one of the spin-out companies from GE is something that takes waste heat and turns it into high-quality water. So can you use that kind of low-grade heat to drive a process that sucks in atmospheric air, dries that air out, collects the water, and then reverses that process time and again? And if you think about water usage, even in a closed-loop cooling system, you still have a lot of makeup water you need. If you put these data centers in places that are under water stress, that's one of the kind of like fringe innovations where you can't get rid of all of the waste heat, but let's make that heat do something useful.
I like that phrase, fringe innovation. Yeah, I completely agree. Okay, Paul, perhaps staying with you while I've got you there, thinking about integrating more closely with energy systems, when you think about data center operators, utilities, energy providers, looking at closer coordination and collaboration, what practical steps are you seeing that help align energy availability and aspects like operational flexibility and long-term planning?
Yeah, it's kind of an all-of-the-above approach, but if you take a high-level view, so our company is talking to really large hyperscale project developers, whether it's with gigawatt scale behind-the-meter generation in very remote locations, as well as in the much smaller scale, kind of like how do you make distributed data centers more efficient. What they all have in common is you're trying to couple something that has the heartbeat of a hummingbird. It's very clear. What happens at these chips moves very, very quickly, loads are kind of moved around, and you're trying to couple that with an energy grid that has the heartbeat of an elephant, right? So it goes boom, 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 and it goes boom, boom. This is controlled by voltage, by kind of frequency controls and all that. How do you couple these two systems together? And it's not trivial, because you can actually create a lot of damage by having a load that is unpredictable, kind of connected to the grid. Historically, if you were building a steel mill, making an electric arc furnace, you wouldn't just be allowed to connect that directly to the grid. There would be all kinds of grid controls and all that. So how these data centers start to interface with the grid is a really interesting area. There's lots of technical solutions available, but if you don't put enough thought into how you design that, you can really get unstuck. And then to the point that Andreas made a bit earlier, how do you make the loads perhaps more flexible? How do you make data centers really good grid citizens? First of all, how do you make sure that they play nicely with the grid? But now can they actually also play a role with massive kind of load kind of management and become grid reinforcing rather than being a burden to the grid? So I think a lot of software solutions being thought about in that space.
Great, thank you, Paul. And any other thoughts from any of the other panelists while we're on that question?
Maybe one point that's often underappreciated is there's a big biogas base in Europe, and more is getting built. And I don't think that's been considered as a source, as an energy source for data centers, but especially for decentralized. especially for decentralized energy provision, that can be a real asset because you can get the power independent of an index or the TTF index and price, so you can get a lot of stability in there. And there's a lot of existing infrastructure that's underutilized. Some of these assets, they don't utilize their full power.
Yeah.
So to be able to play together with that industry could be a big asset in Europe.
Yeah, agreed. So as we then start to think about investment planning, partnerships, what kinds of partnerships or contracting approaches are helping to accelerate access to reliable, sustainable power, whilst also managing that long-term risk? Maybe, Andreas, we could start with you?
Sure. So, I mean, for a lot of technology scale-up, the key thing is committed offtake. And also for planning visibility, for utilities and energy providers, we need those long-term structured offtake agreements. They also help the funding and lowering the cost of capital, which is, in many cases for innovation, is kind of a prohibitive factor. But I think we could build more flexibility into these PPAs. So one idea, and I'm sure the other panelists will have more, is speed to power is the name of the game at the moment. So you might want to pay a premium in the initial phase of a PPA for faster speed to power. And then as you get more grid connection, you might shift that, for example, again, for behind the meter, where you then feed more into the grid and you pay less for the PPA. So that's one example of a potentially helpful structure.
Yeah, that makes sense. And then, Thomas?
Different direction of partnership, but I think partnership with the guys like Microsoft is for early stage startups is extremely interesting and valuable. You know, because it's hard to test their stuff in real life. You know, we're looking at a few startups recently there, where Equinix has a pretty cool sandbox where they have a dedicated little data center where they can run their, whether that's separated liquid cooling or their chips, and really try and see if that works in the real life cases. Like you guys also have invest to procure. So also think if you could also expand maybe and talk about this thing, also super interesting for startups.
Yeah, for sure. And I think, I mean, there's a few different ways that we look to support the portfolio across not only being an investor, but in many cases a buyer, and then a technology partner and go to market where it makes sense. And so we will tend to support our portfolio with as many of the kind of Microsoft programs that we can offer. So like, for example, some of the portfolio will be leveraging things like the Microsoft for Startups program, and we've got access to a number of additional credits over and above, what startups that wouldn't be in the fund would get access to. But we also do a lot of test deployments, but we'll buy from a number of the organizations as well. And so there was a really great case study just recently with VIA, who do high temperature superconducting. We actually did a piece of work with them deploying their technology inside the data center to deliver, I think it was around like 3 or 5 megawatts of power directly to the server hardware, which is phenomenal. You know, that I think was published about 2 months ago. If anybody wants to take a look. And we continue to find work or engagements and opportunities like that. And we'll look to continue to support companies like probably Line Vision's a really great example as well. They offer dynamic line ratings. They have been also working with us from a partnership perspective. So thinking about how can we expand our engagement outside of the fund, but leveraging more of the commercial channels. And so it really depends on each portfolio company. Like some will purely have investment and perhaps a procurement or offtake agreement with us, whereas others will go through that journey with leveraging the other aspects as well. I wasn't expecting to answer that question. Thank you, Tomas, for bringing it up. Good opportunity to do a little plug. Let's then skip through to, with the remaining time that we have, there's a lot of funding programs around in Europe at the moment. There's a lot of de-risking initiatives out there as well. How are you partnering with your portfolios today to enable them to leverage those programs? And do you have any examples you'd be open to sharing? Andreas?
Okay, I mean, I don't have a portfolio, but I can talk about our experience at Reverion. I mean, we've been very fortunate that we almost have a 50-50 share between equity financing from venture capital and grants, and that's been extremely helpful in sort of getting the innovation to the market. And I think a lot of the programs that exist today, beyond that, they can also help bridge the road to project finance. Right, there is now more appetite from project equity providers to invest into platforms doing that, and there is also project finance available, but often these programs help to bridge, sort of the missing middle is almost an overused term nowadays, but to help bridge until these projects are de-risked enough for true project finance. And there's a number of different programs, right? Clean energy investment from the EIB program, which is really large, the EIF Net Zero Tech Call, the EIC Accelerator and Sprint is, for example, a program that we have been using, and these have been really, really helpful.
Yeah, very good. Any other thoughts from perhaps some on the investment side of the house in terms of supporting a portfolio?
We don't really touch anything with first-of-a-kind risk, right? With like this big kind of factory. So this is largely relevant for us. But on the go-to-market, right? And I think when it's about power, transmitting power or power generation, it is somehow less risky than when you actually go into the equipment, which is where the big cost of those data centers are, right? And so for these startups the idea that they're going to all of a sudden start selling, lots of electronics equipment to a hyperscaler directly is never going to work, right? And so how you think about that's where we work with, So do you partner with the semiconductor distributors, the Broadcoms of the world, the STMicroelectronics of the world? Do you go with the guys like the Siemens, the ABB, the Schneider Electric, or do you go with some other kind of architect, more on the software side, architect integrators, or maybe you leverage some Linux or Red Hat kind of open source, but that's going to be a longer route to market, right? So I think we are much more focused there. I think chasing public money is not really relevant for our investment profile.
Yeah, understood. Okay.
Maybe one more thought
Please.
that could potentially link that. So some of these programs, they are not as easy to access for startups by themselves. But one interesting thought is, I think, if you go with a consortium, and you bring in that experience from a grid operator or from an EPC company or from the data center operators themselves, those can be a lot more successful, specifically when we talk now later stage implementation in some of those larger programs.
Yeah, and I think maybe I can expand on that a little bit as well, because, for example, a number of the hyperscalers are working with a European institute called the Net Zero Innovation Hub for Data Centers. So Microsoft are involved, and we have like a exec board seat. Google have the same. Schneider Electric's on there, I think Vertiv, and a few others as well. And they're an organization which are really focused on helping, data centers to de-risk technologies for future deployment in their own operations. And I think that's a really interesting initiative that we're quite excited about, because there's an opportunity to really kick the tires on specific technologies that we may want to look at in more detail. And even Paul and I are working together on a couple of initiatives as well around how we can really collaborate to support each other around identifying the technologies and then again de-risking those in partnership with folks like the Net Zero Innovation Hub and others. But I also think like this ecosystem and the portfolio more broadly is fantastic, because like a number of the fund managers that we work with do a fantastic job of convening all of their LPs and their startups, and so you have these amazing opportunities like you guys are doing today with bringing a number of innovators in the room. It's that incredible opportunity to explore how you can really partner and collaborate together. We have 1 minute and 50 seconds left. I'm going to ask each of you for a very punchy, quick-fire response to which data center innovations excite you the most. I'll start at the end with Andreas and then work away along.
Very predictable, reversible power plants as grid assets that have fuel-flexible generation capacity.
For me, it's all about power density, right? That's the Moore's law, whatever you want to call it, in the industrial Moore's law, this power density.
Yeah, so for us at GE Vernova, although we're excited about just the general surge in demand that this is triggering, it's kind of affected all of our aspects of our business. I think that opportunity of fundamentally changing the reference architecture inside the data center, by more efficient kind of DC to DC conversion using all of the new kind of solid state and power electronics that you can get. That's where there's a real opportunity.
Look, I'd like to say data centers in space sounds exciting, but I'm going to go with more down to earth. I still think cooling, there's so much more to do in cooling tech. It can save so much energy. We're very excited about this.
Wonderful. You have been an incredible group of panelists. Thank you so much for humouring me with answering these questions. And everyone in the audience today, thank you for your time in terms of just hearing us explore some of these aspects. So much to come in this space. I really appreciate the partnership with all of you as we have all connected in various guises over the years. So thank you, everyone.
Thank you.
Yes, after you.
Thank you.